We have a wonderful speaker tonight, Gopal, Gupta. He and his team has been doing some amazing research in AGI, artificial general intelligence. Like most of you, I can't wait to hear from him. But before that, I'd like to thank UTD, Richardson IQ HQ, for providing us this wonderful facility. For the benefit of the community and to create awareness, I think it would be great, Gary, if you'd like to share a few words about IQHQ.
Sure. I'm excited to be here. Enthusiasm here at the IQ is not cliche. People really walk through that door excited to explore something new and engage with people in a different way. As you probably all know, the IQ here it's a collaboration between the city of Richardson and UTD. And the effort is to extend the research and resources of UTD to the community. We're focusing on innovation, commercialization, and entrepreneurship. And again, it's really exciting that we're able to bring people together. And I'll just end by saying that really what we're trying to do is we're trying to bring the local business and community together with research done by faculty and students in a way that allows both groups or all groups to network and to share ideas. So welcome everybody. I hope you enjoy your evening.
First of all, thank you all for coming over. I understand, driving here in the evening time is always a challenge. So very happy to see you here. And we've been doing this for 5 years. And personally, I've benefited by learning because I can't do it alone. So the first thing that we're doing is a workshop on generative AI. Large language models, ChatGPT, text-to-image models, like Dolly 2, Dream Studio, things like that. So we'll go over how these things work, and we'll teach you how to actually create stuff. And if you're a developer, then we'll have optional coding labs. But if you don't know coding, no worries. You don't need to, you'll still learn a lot from this.
I'm going to be talking about artificial general intelligence. So that's sort of the holy grail of AI, where you're trying to build systems that are as good as humans. So I'm going to qualify that a little bit in the sense that I'm interested in systems that are as good as humans, but not in the robotic sense, but basically only in the reasoning sense or learning sense, sort of symbolic sense. So pendulum has swung, the last 10 years completely the other way, where AI has become synonymous with machine learning or deep learning. But before that, one could say that AI was synonymous with automated reasoning. If you walk through immigration these days, you will see that you never have to, you actually don't talk to a person anymore, because you scan your passport and you look into the camera, and a machine learning system, a model, tells whether the two pictures are the same or not. So basically what has been done is we learn the function that tells if two faces are the same. So passenger arrives, scans passport, picture also taken by the camera, and then you feed it to the model will tell you if it's the same or not. So if you look at AI over the years, there have been many successes. So today, machine learning, data science, all these things are pervasive technologies, automating loan approvals. I'm sure all of you are working in computing industry. You're probably using it. College admissions, you could use it, right? You give it applications from, last, 10 years. It learns the function that maps, given the data of a student, admit yes, admit no. Then of course, Siri, Alexa, face recognition, speech processing, all these are major applications. Of course, ChatGPT today. So of course, applications in natural language processing, and you've heard of large language models, GPT-3, which is, GPT-3 is the system on which ChatGPT is based. So it's a machine model trained on billions of lines of text with 175 billion parameters and so on. As we know, it can write original prose, poetry, letter drafts, CVs, essays, legal briefs. But all of this is based on pattern matching. So there are many limitations that machine learning technology has. So these systems are opaque. It's very hard to gain insight, black boxes. So there's a problem with interpretability and explainability. They encode correlation, not causation. You cannot tell whether one is cause of the other. Cannot do symbolic reasoning, planning, computationally expensive. So as humans, we will only use 12 watts of power, but these machine learning systems use massive amount of these GPUs and kilowatts or megawatts of power to train themselves. You need large amount of data, all kinds of, classic example where you can take an image and then add some noise to it, and the classification will change. So from panda it goes to a gibbon, but this is the most amazing one where school bus, and then you add some white noise or some noise, and then it is classified as an ostrich. So not good. So machine learning technology is great, don't get me wrong, but it's not a panacea for everything, because at the end of the day, it is pattern matching. So actually the technology of this large language model, as it is called, has been around from 2017. I think the first system that was developed was BERT by Google. And then OpenAI came along, and then they had GPT-2 and GPT-2, GPT-3, and now GPT 3.5 or GPT-4. And then they discovered it was actually difficult to make GPT-3 hold a conversation. So they sort of built a system that by adding some supervised learning and reinforcement learning, so that it will respond to questions. And that became known as ChatGPT. And all of a sudden, it's right, everybody's talking about it in the popular press. And then, of course, you've heard of DALI system, where, again, an example of generative AI, where it generates something. In this case, you can just ask it to make up a painting, artwork, with some textual description. So you say 2 cats playing a chess, it will generate this for you. So, okay, so large language models, of which ChatGPT is the most well-known example. What someone would write if they had seen, billions of sentences of that, that have been written in the past. So for example, consider this sentence: the best thing about AI is its ability to ... and you have to figure out the next word. ChatGPT or GPT-3 does. It actually computes, given all this data, computes the word with, probability that it will come after, will be the next word. So it could be learn, predict, make, understand, do, with these probabilities. And then of course, you would say, well, pick up the one with the highest probability. But then you will get a system, you will get text that kind of looks jaded, doesn't look human-like. So one of the things that ChatGPT or GPT-3 does is that sometimes it will pick the second or the third or the later choice. So that every time you ask it something, you'll get a different text, like a human. So that's what it is doing. It's basically predicting. And likewise, DALI system is probably predicting the next pixel based on the correlation, given this or collection of pixels. So it's generative in the sense that you are generating the next word, the next pixel, or next whatever. So you give it a prompt, and it will guess the next word based on your prompt or the context that you provided. And it actually gives fluent, topical, and coherent sounding responses, so that's really nice. So it lacks precise logical reasoning, obviously, lacks grounding in specific evidence. It can fabricate information. It can actually, hallucinate, as they call it, produce new stuff. Then of course, because it's pattern matching, there is no trust, transparency, no idea if it's going to be the correct stuff, and so on. If you, for example, ask what is 2 + 2, it's not actually doing any computation. It's going to look at all the text and see what people said about 2 + 2. So if many people said 2 + 2 = 5, it might actually get confused and say, yeah, 2 + 2 is 5. So no thinking going on, pure pattern matching. Many other problems, but it's a great aid for us. Like the calculator for arithmetic computation, you could say. A lot of people are concerned that it will be used for cheating and all that stuff by students. So, I guess one solution is that you have to change your homework. Don't give them simple stuff. To just write an essay on this. You have to, just like the calculator, where, right, when calculators came along, you no longer can say, well, perform these computations. You have to ask, more interesting problems. The question is, can large language models do it all? So that's basically the hope. In fact, that's what the machine learning community says, that eventually we'll build machine learning systems that will be as smart as humans, and that's what the autonomous driving people said. All you need is machine learning, but we're finding out that's not true. We look at the objects, we see a pedestrian, we see a traffic light. That information comes and sits in our brain as knowledge, And then we reason with it. We say, okay, red light, I'm going to stop, right? So we're using reasoning for driving. We are using sensing and machine learning equivalent technology for identifying the objects, recognizing things. But we're not our driving is not like these autonomous vehicles. If I see this pattern, then I have to take this action. It's not instinctive, right? Like the autonomous vehicle people would want it to be. So there is a tension between learnability and this computational irreducibility. And so essentially not everything can be learned. And I would say perhaps, again, I could be wrong, weather prediction is one of those things where you really have to compute. I don't know how weather prediction is done today, but you basically have to compute, you simulate at the cell level and figure out, and so you really cannot just abstract it away by some function or learn it. So how do we achieve AGI? So current approaches, if you look at them, for example, autonomous vehicles, they try to tackle everything at system 1 level, only machine learning. So for example, see all this research where they're trying to build systems that will answer questions against a picture. So the way they do it is they'll say, okay, let's get tens of thousands of pictures. For each picture, pose 5 questions and 5 and corresponding answers. Throw it to the machine learning system and let it learn a model. And then you give it a new picture and a question, you expect an answer. But that doesn't work very well. We work in a different way, and if you really want to build these AGI systems, then you have to do the same thing. So to emulate however, the large language models present an amazing opportunity, which is that we can use these LLMs for discovering knowledge. Okay, what do I mean by that? I'll explain in a second. But then we use these common sense reasoning system or automated reasoning system for processing this knowledge. So try to emulate the human as much as possible. So that's what we're doing basically. So using the large language model, so for building, for example, chatbots that understand really what you're saying. You can take these LLMs or large language models like GPT-3 or ChatGPT, give it a few examples and to tell it to extract the knowledge that you're interested in. So for example, if I give this sentence to it, after I've trained it with just 10 examples, say Billy's coffee shop provides a kid-friendly venue for Chinese food at an average price point in the Riverside area. It is highly rated by customers. I can train it to extract the knowledge, and the knowledge is expressed in the form of predicates. That the name is Fitzbilly's, type to eat is a coffee shop, cuisine is Chinese, and price range is moderate, customer rating is high, family friendly, yes. So once I can extract this knowledge using GPT-3, just like I would understand that and record that knowledge in my head, now I can process it using my reasoning technology. So this is a very narrow domain. So okay, takeaway. So a little bit of history, right? Both learning and reasoning have been developed through research done over the last 50 plus years. Right? Machine learning, deep learning, very prominent technologies everywhere. And as computing power has become available, more and more data, right? Extremely useful, probably used for, and you see how many data science and machine learning jobs are advertised, so everybody's using it. Tremendous potential for the industry, but we have not realized, right, human-like intelligence. So even though we have ChatGPT and all these things, still far away. Okay, so how can UT Dallas is departed? So AI, so one is, of course, we have the Center for Applied AI and Machine Learning, which, Professor Doug DeGroot, who's here. UT Dallas has this wonderful model where you actually get to keep the intellectual property if we work with you. UT Dallas takes a very, very tiny, very small share of, some proceeds, but you get to keep the IP. So if you're interested, we can help you with any kind of, so these are the companies that we Vistra Corp, but these are companies where we help them predict electricity prices, spot prices. And also wanted to mention that we have actually explainable AI technology that is available for licensing, if anyone is interested. So as we know, major problem with machine learning tools is explainability and interpretability. We have this system called Fold SE. So you give it a data set, like loan processing data set or something, it will actually learn rules. So for example, this is a very well-known adult data set, which predicts who will make more than 50K, given marital status, capital gains, education. In fact, you can find deprecated versions of these tools for free on GitHub that we have published. So if you're interested, you can try those. But if you want, more succinct rules, like, your data set is 250,000 records, but you only want to explain it in 3 rules, we can do that for you. Okay, then if you're interested in acquiring a degree in AI, then we have this executive master's program in software engineering, where it's called software engineering, but half the courses are in AI, artificial intelligence, NLP, machine learning, big data analytics, and so on. I mean, somebody built that machine learning system, so all you have to do is feed it the data, right? As a user, you feed it the data. So if you are a bank loan officer and you want to build a model, then you will acquire whatever TensorFlow or whatever tool that you can get, a bunch of machine learning tools. You get those tools, feed your data, and out comes a model. I mean, the coding was, of course, people who build the actual machine learning system that you're using, a huge amount of work and coding. So even ChatGPT, right? You're not doing any coding. You get the system. OpenAI people who did all the hard work for you. As a user, you don't do any coding.